Hey again, welcome back to Mr. Ace Math. This lesson is on percent of change. Some stuff you should know before you get started are what percent is in general, basic multiplication and division, how to use algebra, and how to solve equations. So make sure you understand those and let's get started. So first of all, what exactly is percent of change? Just think about the words exactly as they are. Okay, it's the percent of value increases or decreases from its original. In other words, how it changes. There are two types of percent of change and they're pretty straightforward. The first is percent increase, and what do you think happens there? It's when the value goes up from its original. And the other is percent decrease, and pretty much that's pretty straightforward. It's when the value goes down from its original. So let's start with an example. Remember that the percent of change is the percent of how much a value changes from its original amount to a new amount. So let's say we have this problem. There are 10 members in the school debate team. Next month, 3 more people joined. What is the percent of change of the debate team? So we're saying that we had 10 members in a debate team. So we've got 10. 10 people, that's the complete set. There's 10 out of 10, that makes 100% of the group. And we're saying that 3 more people joined. Well, if those 3 more people join, what percent of the original group was that? How much of the original group does 3 make up? Well, originally we had 10, but now we're just talking about 3 out of 10. And that's not 100%, that's 30%. So the percent of change is 30%. And it's important to know that it was a percent increase because they went up by 3 people. But what if 3 people left the debate team? Well, then what would happen? Those 3 are gone. We had 10 people before, but now we have a decrease of 30%. Okay, because we went down by 30%. So when we added people to the original amount, when the original amount of people went up by 3, that was an increase of 30%. But when the team decreased by 3, that was a decrease of 30%. So whenever you go up in value, it's an increase, and whenever you go down in value, it's a decrease. Let's start with the percent of change formula. There's 2 that you need to be familiar with, but they both pretty much mean the same thing. One's just better in certain situations. This is the percent of change equals new value minus the original value over the original value times 100. What this does is this actually gives you the second formula, which is this one. The percent of change equals the amount of change over the original value times 100. This, the new value minus the original value, is the same exact thing as this. It gives you the amount of change. So make sure you understand those formulas, make sure you have those down, and let's go on to a few examples. Let's say a value changes from 100 to 120. Well, it's changing from 100 to 120. So let's start with our formula, and then let's plug in what we have. We're saying the new value is 120 because it becomes 120. That's what it's going to end up being. So that's our new value minus the original value. We started where? We started at 100, so we're going to have that as our original value. And then again, 100 is our original value, so we put that in the denominator. So now we do our math. What's 120 minus 100? Well, that's going to give us 20. So what's 20 divided by 100? That's going to give you the decimal, 0.2. And 0.2, we still have to bring down our times 100. So we bring that down, and then 0.2 times 100 is going to be 20%. So what that means is the value changed by an increase of 20%. Well, how do we know it was an increase? First of all, our percent is positive. That tells us that it went up. The second thing is just think about it by common sense. We went from 100 to 120. So if we started at 100 and we ended at 120, our value went up. Therefore, it's an increase. How about this one? A value changes to 1,000 from 1,800. Now I've changed the wording a little bit, but no matter, we're still going to do the same exact thing. Let's start by bringing down the formula. And now we just have to plug our values where they belong. Well, what's our new value? Well, that's going to be 1,000. Why is it 1,000? Well, that's because it ended up being 1,000. That's our new value. After the changes happening, our new value is 1,000, so that's going to be our new value. Well, what's our original value? We said that it changed from 1,800, and since it changed from 1,800, that's our original value. And again, our original value is 1,800, so we'll plug that in for the denominator. So now we've got 1,000 minus 1,800. And what's that going to be? Well, when we do the math, that's going to end up being negative 800. But what's negative 800 divided by 1,800? That's going to give us a decimal of 0.444 repeating, but it's a negative. So it's going to be negative 0.444 repeating going on times 100, because we still have to bring down the times 100. And then we bring down percent of change equals, and after we multiply this by 100, we're going to get roughly negative 44.4%. Remember, with percents, you never really use repetition, so you'll just round it to the nearest whatever is being requested. Here, I rounded it to the nearest tenth. It doesn't really make a difference. Make sure you keep in mind what your teacher is asking you for. If your teacher asks you to round to the nearest tenth, round to the nearest tenth. If they ask you to round to the nearest whole number, do that. If they ask you to round to the nearest thousandth, you have to do that. But what we're focusing on is just the calculational part, the computational part, what our percent changes. So in this example, it's negative 44.4%. And it's important to note that this was a decrease of 44.4%. And we know that it's a decrease because, well, for two reasons. The first is that it's negative. And the second is that we went from 1,800 to 1,000. So if we went from 1,800 to 1,000, we went down in value, so that represents a decrease. How about this example? A value changes by 16 from 20. Well, this question's a little bit different because in our other questions, we were given the original value and the new value. So we could subtract to find out how much it changed. Here, we're not given a new amount and an original amount. We just know how much it changed by. So we're going to use the second formula we were given, which is percent of change equals the amount of change over the original value times 100. Because we have two things. We have the amount of change, how much it changed by, and the original value. Well, what's my amount of change? How much did it change? Well, it changes by 16. So right away, we know that our amount of change is 16. And what was the original value? Well, the original value was 20 because it says that it changed from 20 by 16. So 20 is our original, and we'll plug that in there. So we've got 16 divided by 20. And what is that? That's going to be 0.8. And we still have to bring down our times 100. So we've got 0.8 times 100. And what's that going to be? Well, our percent of change is going to be equal to 80%. Now the question is that a percent increase or is that a percent decrease? Well, the honest truth is we don't know because we don't know what it ended up being. We don't know what the new value is. We just know that it changed by 16. That means that it could have ended up being 16 more than 20, or it could have been 16 down from 20. But we don't know what that is, so all we can say is that the value changed by 80%. How about this one? A value changes from 125 by 90. Again, what do we know? Well, we know our amount of change because it's saying that we changed by 90, so that's our amount of change, and we'll plug that in. And then our original value, we know that our value changes from 125. So that's our original value, and we'll plug it into the bottom. So now we've got 90 over 125 times 100. Well, what's 90 divided by 125? That's going to give us 0.72. And we still have to bring down our times 100. So now we've got 0.72 times 100, and that's going to give us our percent of change, which is 72%. So we know that our percent of change is 72%. Well, was that an increase or was that a decrease? Remember, like our last example, we don't know what the new value is. And because we don't know what the new value is, we can't state whether it's a percent increase or a percent decrease. We can only say that it changed by 72%. And here's a word problem. A shirt costs $150. It goes on sale and now costs $100. What is a shirt's percent of change? Well, let's start with our formula, and let's start with what we know. We know that the shirt costs $150. and it goes on sale and now costs $100. So let's start with our formula with the new value and the original value. Why this formula? Because we know what our new value is and we know what our original value was. So let's plug those in. Let's start with the formula, bring that down, and our new value is 100 because that's how much the shirt is after the sale. And the original value was what the shirt cost originally, which was $150. So we're going to put that in for our original value. And again, the original value goes into the denominator as well. So now I've got 100 minus 150 over 150 times 100. Well, what's 100 minus 150? That's going to give us negative 50. And what's negative 50 divided by 150? Well, that's going to give us the decimal, negative 0.33 repeating. And we still have to bring down our times 100. And after we multiply, that's going to give us our percent of change, which is going to be negative 33.3%. Again, remember, when your decimal goes on and on like this, you don't write that into your percent. You normally round it to whatever place you're being asked to round it to. So what is this? Is this a percent increase, percent decrease? Can we even tell? Well, we know it's a percent decrease. And the reason why it's a percent decrease is for two reasons. One, the answer is negative. Since we have a negative, that represents a decrease in value. The second is that we just look at our numbers. We went from $150 to $100, and that went down by $50. So that's exactly why we have a percent decrease. How about this word problem? A school has 1,000 students. 250 more students enter the school. What is the percent of change? Well, think about what we have here. We have how many students are in the school, so we have the original amount of students in the school, and then it says 250 more students enter the school. So we can use this formula. The percent of change equals the amount of change over the original value times 100. So let's plug in our values. We know that the school changed by how much? Well, it says by 250, so we'll plug that in. And what was the original number of students in the school? Well, we know that's 1,000, so we'll plug that in. So we've got 250 over 1,000 times 100. And what's 250 divided by 1,000? That's going to give us the decimal, 0.25. And we still have to bring down times 100, so we'll just bring that down. And now we've got the percent of change equals 0.25 times 100, which gives us 25%. Now, is this a percent increase, a percent decrease, or is it just a percent of change that we can't tell? Well, it's actually a percent increase. And even though most of the time when we use this formula, we can't tell, based on the wording in the problem, we can. It says 250 more students enter the school. And because we know 250 more students enter the school, that means there's going to be an additional 250. So our value is going to go up. Therefore, it's a percent increase by 25%. So here's your pause and practice. Just pause and practice. When you're done, unpause the video. After a 3, 2, 1 countdown, your answers will be displayed. Go. So let's go over our answers. For each of our questions, we had to determine A, the percent of change, and B, if it was a percent increase, decrease, or just a change. Number 1, it was a change of 171% and it was just a percent of change. Number 2 is 100% and it was an increase. Number 3, it was negative 36% and it was a decrease. And for number 4, it changed by 20% and it was just a percent of change. And number 5 we'll go over together on the next page. So our word problem said you have a business and this month you made $7,000. Last month you made $5,000. What is the percent of change from last month to this month's revenue? Is it a percent increase or decrease? And explain. So we know that this month we made $7,000 and last month we made $5,000. So that means we had an original amount and a new amount, which means we can use the first formula. So what was our new value? Our new value, the amount we made this month, was $7,000. And our original value from last month was $5,000. And again, we'll plug that $5,000 in for our original value in the bottom. So now what's 7,000 minus 5,000? That's going to give me 2,000. So what's 2,000 divided by 5,000? That's going to be 0.4. And we still have to bring down our times 100. So what's 0.4 times 100? That's going to be our percent of change, which is 40%. Now, was it a percent increase or decrease? Well, it was a percent increase. And the reason why you can tell it was an increase was for two reasons. One, it's a positive value. And two, because in our wording in the problem itself, it said that you started off at 5,000 and this month made 7,000, which means that you actually made $2,000 more this month than you did last month. Therefore, again, your revenue increased by 40%. So let's review this lesson. The percent of value changes is called the percent of change. There are how many types of percent of change? 2. Those two types of percent of change are percent increase and percent decrease. Percent increase is when the original value goes up. Percent decrease is when the original value goes down. The two forms of the formulas that can be used are percent of change equals the new value minus the original value over the original value times 100, or the percent of change equals the amount of change over the original value times 100. This formula is very good for when you have your new value and your original value, and this formula here is best when you only have the amount that the original changed by. An easy way to determine if a percent of change is a decrease is when the answer is negative. True or false? You can always determine when the percent of change is an increase or decrease. False, because sometimes you'll know how much the amount changes by, but you won't know if that value goes up or if that value goes down. Only when you know both the original and new values can you say if the change is an increase or decrease.
Don't forget to like, share, and subscribe.
And thanks for using Mr. Ace Math. Don't just pass math, ace it.